pivot index. So given an array of integers nums, calculate the pivot index of this array. The pivot index is the index where sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the right of the index. So what does it mean? I shall take this example. 1, 7, 3, 6, 5, 6, 6, 5, 6. So we'll start with the first index. In this left side, do you have any elements? No. So left sum equal to 0. And for 1, the left sum equal to 0. And the right sum would be 7 plus 3 plus, which is not equal to 0. So go to the second element, that is 7. So for 7, left sum is 1. So left sum is 1. Then for right, 3 plus 6 plus 5 plus 6, which is greater than 1. So left and right sum are not equal to, are not equal. Then go to the third element, 3. Here the left sum would be 7 and 7 plus 1, that is 8. And right sum would be 6 plus 5 plus 6, 6 plus 6, 12, 17. Both are not equal. Then come to this 6. Here, if you see the left sum, 1 plus 7 plus 3 is 11. Then go to the right part, 5 plus 6. Even the right part is 11. So we can see 6 is the element where the left part of the element and the right part of the element both are adding up to the same number, that is 11. So that is what I have told you. The pivot index is the index where sum of all the numbers strictly to the left of the index, strictly to the left of the index is equal to the sum of all the numbers strictly to the right of the index. So we have to return this index, that is the pivot index. In this case, 6. The index of the 6 is 0, 1, 2, 3. So 6 is in the third index and this would be the output of the problem. If the index is on the left edge of the array, then the left sum is 0. If you see in the starting part, index is in the left edge of the array. So the left sum will be 0 in this case because you don't have any other elements next left to that. So as I said, the left part has summing up to the 0 because there are no elements to the left. This also applies to the right edge of the array. So if you consider the right edge of the array, here the left sum would be the entire element of the array till the index previous to that. So 1 plus 7 plus 3 plus 6 plus 5. But what comes to the right part? Nothing is present. So the right sum would be 0 in this case. That has been told here. Now return the leftmost index. If no such index exists, then return -1. So here the index leftmost index which we got is 3. So if no such index exists, return -1. Let's consider an example for that as well. 1, 2, and 3. So start with the 1. Do we have any left part? No. So for 1, left sum equal to 0. What about right sum? 2 plus 3. So 5. So both are not equal. Then move to the second. So here the left sum would be yeah. If you consider second, here the left sum would be 1 and the right sum would be 3. Left sum equal to 1, right sum would be 3. So left and right sum are not equal. That is not there. So again, now move to the third element. That is 3. For 3, the left sum would be 1 plus 2. That is nothing but left sum would be 1 plus 2, that is nothing but 3, and right sum would be nothing, so r equal to 0. Here left and right sum are not equal. That means we have not found any index where the left sum of the array is equal to the right sum of the array. In such case, we just need to return the output as -1. There is no index that satisfies the conditions in the problem statement, hence we are returning -1. Next, consider the last example. So the first index, it's pointing to 2, left sum is 0, then the right sum would be 1 minus 1, so that is 0. Hence you got the index value where the left sum is 0 and right sum is also 0, which means both are equal. Hence the index of this pivot element is nothing but 0, so that is the pivot index we are returning. If there is another example like 1, 2, 3 and -2, at first if you point to 1, here 0 and here it will be 2 plus 3, 5, 5 minus 2, that would give you 3. 3 and 0 not matching, 0 and 3 not matching. Then you come to 2, here left part is 1, for right part 3, then -2, 3 minus 2, 1. So yeah, left and right sum are matching, hence this is the pivot index, that is 0, nothing but 0 after that 1, so 1 is the pivot index. Now how to write the logic of the program. Once you get the sum of the entire array, let's say we are in this index, okay? So we have the sum of the entire array as 28. From 28, from the sum of the entire array, to get only the left sum, you need to subtract right sum minus the current element. Got it? So at first you have the entire sum of the entire array equal to 28. 28. Okay. And we are pointing to the index 3. To compute the sum of the left array, what do we need to do? We have to subtract the entire array minus only the right part of the array and the current index value. That is, subtract the entire sum of the array, subtract this minus, we need to perform the subtraction of entire sum of the array minus only the right part minus the current value. So sum equal to sum minus sum of the right part of the array would be sum 1. How do we find the sum 1? Incrementally you are performing the sum 1 array, right? If you are in this index, sum 1 would be equal to 1. So again, if you come to this, sum 1 would be equal to 1 plus 7. Then if you come to the 6 as element, then sum 1 would be equal to 1 plus 7 plus 3. So in this way, sum equal to sum 1, that is the right part of the array sum, minus sums of I, that is the current index value. So all this would give you the left part. So this left part is equal to right part. What is right part? As I said, it is nothing but sum 1. If left part is equal to right part, that means here is the if condition. If left part equal to right part, here we compute the left part. How do we compute the left part? We take the entire array, then subtract the right part of the array from that, right, the sum 1. Then from that, subtract the current value. So you get the left part of the array equal to sum 1. Sum 1 is the right part of the array. If both are equal, left and right part are equal, then you just need to return the index of I, return I. If What if we go through the entire array and we don't get any such index where both are matching? Then we need to come out to the for loop and return -1. Yeah, before performing this -1, return -1, here again, if none of the condition passes, if this condition is not equal, left part of the array is not equal to right part of the array, we have to increment the sum value, right? Sum1 would be equal to sum1 plus nums of I. So that initially if it is pointing to 1, sum1 equal to sum1 is initially 0, 0 plus nums of I 1. So sum1 will become 1. So once you get sum1 equal to 1, then you go to I equal to 2. In that case, you check the condition whether entire sum equal to 28. 28 minus sum1 is nothing but 1. 28 minus 1, 27. Minus nums of I. Nums of I would be pointing to 7 now. So 28 minus 1 minus 7. That will give you 20. Is 20 equal to this part of the array? 6 plus 6, 12. 17 plus 3, 20. If both the right and left part are equal, yeah, left part you get is as 20 here, then sum1 equal to 1. If 20 equal to 1, no. In that case, you need to increment the value of sum1. Sum1 equal to sum1 plus nums of I. Sum1 equal to 1 plus the current value, that is 7. So here sum1 is performing nothing but the sequential sum of the array at the each index. So if none of the cases passes, you just return -1. So we'll write the program. As I said, at first you need to find the sum of the entire array in sum equals 0 for int I equal to 0, I lesser than nums dot length I plus plus sum plus equals to nums of I. So here we are finding the sum of the entire array. Once you get the sum of the entire array, initialize another variable sum1 equal to 0 so that we'll get sequential sum of the array at each index to compute the right array sum, from which we can find the left array sum also. So for int I j equal to 0, j lesser than nums dot length and j plus plus, here we have to check the condition if. How do we find the left sum of the array? If the current element is pointing to 7, the total sum minus right sum of the array minus the current index value. So total sum is sum minus right sum of the array. Right sum is nothing but sum1 minus current index value is nothing but nums of I. If that is equal to right sum of the array. This is for computing the left sum of the array. Left sum of the array. If this left sum of the array equal to right sum of the array, that is right sum is nothing but sum1. That means we have to return the I value. If this is not happening, we have to incrementally find sum1 plus equal to nums of I. So that at each iteration we find the right sum of the array. If none of these cases are passing till the end of the array, we return -1. We shall run this. If okay, this is nothing but nums of j. Here also j, again j. Yeah, we'll submit this. Yes. So This requires a little bit of thinking. At first you will have the entire array. From that, after you find the sum of the entire array, you find the sum of the right sum of the array and compare it with the left sum of the array, and you find the index to be returned. So I hope you guys have understood the problem. If you have any doubts, please put that out in the comment section and subscribe to the channel. We'll come up with another problem in the next video. Thank you.